So we're going to cover advanced xSchedule, which means I'm not planning to spend a great deal of time going through the basics. I'm assuming that you've already used it to some degree and you're kind of reasonably comfortable setting up a straightforward schedule. And instead what I'm going to do is I'm going to focus on some of the more advanced features. I've looked at the questions that have been posted and I'm going to try and address each one of those. And then if time allows at the end, we may spend some time and answer some additional questions. But I'll try and give you an idea. All right. Anything more than the basics with xSchedule, because this kind of tells you how xSchedule works out what data to send out to your lights. xSchedule has a pipeline of activity that occurs on every frame, which allows it to blend together multiple things before it finally pushes the data out to the controller. This is the thing that makes xSchedule so powerful. But unless you understand what's going on, you will get lost in understanding how everything works. So starting from the left, what xSchedule does, and one of the reasons why xSchedule doesn't use as much memory as xLights, is that it doesn't need to load the whole sequence. But what it does need to do is it needs to prepare a frame worth of data to send out to the network and out to all of your controllers. So it starts off by creating that frame, and that frame is typically the number of bytes that you would have represented in your xLights. So for instance, if this is my xLights, it would be a frame containing in this case, just over 59,000 channels, 59,358 channels. So it would create a block of channels, and then it would start to apply data into those channels. And that data can come from multiple sources depending on how you've configured your particular playlist step. Most people are basically just playing a playlist, and typically it's going to be one of these three. And these are kind of in the order in which they can be chosen. So if you've manually triggered a playlist, that will always take priority over any schedules, etc. And so that will be the thing that plays, and it will load that FSCQ file or do whatever that is that that playlist wants to do inside the buffer. If you haven't manually triggered a playlist, there's also a queuing functionality within xSchedule. I don't think anyone's actually using it, but xSchedule has a set of APIs that allow you to tell it to add this song to a queue of songs to play, and xSchedule will then play those songs in the order that they're added to the queue. And I'll show you the API for that in a little while. And then finally, if there is no queued playlist set up, it will play whatever's actively scheduled, but it only plays the highest priority one. So if you have multiple playlists that have been scheduled to play at this particular point in time, it will look at the priority attribute and it will play the highest priority one. Now, if you have two playlists with the same priority, it will generally pick the first one it finds. I think that's right. Although, to be honest, I don't guarantee how it will resolve that conflict. It will do what it will do. Okay, so having loaded that data, so read that FSCQ file, loaded that data into the frame, it then comes along and looks to see if you have any background playlist defined. If you have a background playlist defined, it will then add that background playlist data on top of the data that it's already loaded. Now, because if your background playlist is an FSCQ file, which also happens to have your 59,000 channels, then your background playlist will effectively overwrite your sequence. And that's one of the reasons why when you've got a background playlist, if you're using an FSCQ file, you need to limit the channels that it overwrites, because you probably don't want it to overwrite all of your channels and hide your sequence. But there's also the ability to blend the data in. If you're using an ESCQ file, then automatically, of course, it only loads the data into a limited set of channels. So that's how the background playlist works. Then if you happen to have fired up Tetris at the same time, Tetris will now get applied over the top of your sequence and over the top of your background playlist, and it will load onto whichever matrix device you've said Tetris should play on. And then you can have on top of that a whole bunch of event playlists. So event playlists are just normal playlists, except instead of being triggered by a schedule or being triggered by someone manually saying, I want to play this, they're triggered via the event playlist API. And you can have as many of these as you want. And you can tie them to a button. You can still control them just like any other playlist. The only thing you can't do is you can't schedule them, although you can schedule a playlist which triggers an event playlist. So it's a bit of a Russian doll sort of situation where there's always a way to wrap something in something else in order to get something to work. And the idea of event playlists is, an event playlist is something you want to apply selectively at a particular point in time. Some useful uses for it is, you might want to, I don't know, have a button which temporarily overlays a piece of text onto your matrix to tell people to turn their headlights off, or you might want to, based on a button press, trigger a video or whatever. So those event playlists get laid over the top. Then there is overlay data. To my knowledge, no one's using overlay data, but overlay data offers an API which allows you to actually send pixel data from a third-party program onto xSchedule and blend it in or overwrite existing data. So if you wanted to write an entirely separate program which had data that you wanted to display on your pixels, using that API, you could push that data in and it would then overlay on top of everything else. Then you've got your output processing. So your output processing is where you can do things like remap channels, apply dimming curves, do dimming, all of that sort of stuff. And then finally, the global brightness is applied, and only then is the buffer finally ready to be sent out to your controllers. So there's a hell of a lot that goes on in preparing a frame of data that gets sent out to your lights, and through the appropriate choice of the right sort of thing, whether it's a background playlist, an event playlist, etc., the output processing, you can typically achieve most of the things that you might want to achieve. It's just a matter of choosing the right mechanism to do so. Now, once you get to all of this, of course, then you run into the issue of, well, how do I do something, and choosing the simplest way to do something, because often there are 2 or 3 ways in which you can achieve an outcome, and you always want to choose the one which is the simplest and easiest to do. And sometimes that's not incredibly obvious, and sometimes it won't even involve xSchedule. It'll involve, a remote Pi or something. And so working out the best way to achieve something is really important, and often the first thing you think of will not necessarily be the best thing. So let's go to our advanced playlist items, because I want to go through and run through each one of those. Now, I've done this before, but I want to spend a little bit of time on it. So I don't run my scheduler in advanced mode, but you can always get to advanced mode just by right-clicking here and adding an advanced playlist, and it moves it into advanced mode. With advanced mode, you right-click here, and then you get all of these playlist items that you can use. Everyone would be familiar with FSCQ. So FSCQ is basically the way in which you play a regular sequence. You would typically put the FSCQ file in here. Most of the time you would overwrite the data. You remember in the pipeline, overwrite basically clobbers whatever might have been written into that channel in earlier parts of that pipeline with whatever is in this FSCQ file. But you have a number of other ways in which you can choose to blend in the data. Limit channels allows you to limit the channels that are actually applied. And so if this was a background sequence, you would typically want to limit the channels to say, no, my matrix starts on channel 3000 and goes for 2000 channels, and therefore when I apply this FSCQ file, I only want to read out that data and overwrite what's on my current display already. And that's how you constrain what this FSCQ actually puts into the frame. Override audio is all very straightforward. It basically allows you to change whatever the default audio was associated with the FSCQ file. Fast start audio, what that does is at the expense of some time when the when the playlist first start, it will actually go through and pre-process all the audio files and get them ready for playing. That can consume a significant amount of memory, and it adds a significant pause at the beginning of the sequence, but once the playlist starts, it means that all the data is ready to go, and so the song changeover will be a lot crisper. It will move a lot quicker. Otherwise, you can get up to a second or two, depending on the size of the audio file, while xSchedule prepares the audio file for playing. And override volume allows you to do by song, change the volume that's played. So that's FSCQ. You'd all be familiar with that. I'm sure you've done that before. ESCQs are a little bit different. So you'll notice in ESCQ files, you don't get to limit the range of the channels, and that's because the ESCQ file itself actually has all of that data embedded. An ESCQ file is basically the exporting of a single model's data. You do still get to control, however, how that data gets blended in. And so an ESCQ file is a great thing to use for your background sequences and the like, where you typically just want to, put out a tune to sign or something. That's where you'd mostly use that. An ESCQ file has no timing information associated with it. So consequently, ESCQ files don't generally give you very sensible duration timing. FSCQ video. This is a bit of a combined one where it combines together the playing of an FSCQ file with the playing of a video file. When you're playing a video file, you need to position where it is. Typically, you'd have a projector attached to your screen, and so you would drag this window over onto your projector and position it and make it full screen or whatever else it is that you need to do, and that's where the video would play. Topmost window just forces that window to be in the foreground, so you don't end up with something overriding it. Suppressing virtual matrix means if you've also got a virtual matrix, the video will actually make sure that the virtual matrix never takes priority over the video. The blend mode here relates to the way the FSCQ data is blended. The limit channel's the same. The override audio is the same. You also have the ability to cache the video. The power of caching the video, the problem is if you're just playing one video and it's not particularly big, you're generally okay. The problem you run into is if you're playing a very large video file and you're forcing xSchedule to resize the video, you can run into performance issues because processing video is just so compute intensive, and you really don't have a lot of time each frame to be processing things. So if you click cache video, what xSchedule will do is it will actually spin up a separate thread which will attempt to read the video file and cache up to 20 frames of the video ahead of when they need to be played. And that will generally give you better video performance when it's playing. Loop video, if your video file is not as long as your FSCQ file, then the video will loop back around and start replaying. And then you've got your priorities and fade in and fade out. This is for your video, so you can have your video fade in and out at the end if you so wanted to. So that's FSCQ and video. Video is basically the same, except obviously it only has the video settings. So you would typically you'd use this as a second step within, a second item inside a step. Audio is useful if you just want to play a bunch of music. So I don't know, during the day, let's say you just wanted to play randomly out of a library of Christmas music and broadcast that. You could add a bunch of audio items. Obviously, this doesn't actually write any data at all into the render buffer. And so what will happen is xSchedule will keep on sending out black to all of your controllers as a result of that. But it won't override anything either, so you can have that. Image is really useful if you wanted to put a static image or maybe a GIF image onto a projector. Again, you would position that onto your projector. You choose your image file. and it would just display. So you might have your, rather than having your tune to sign as a video or a bunch of data, you just have your tune to sign on a projector and display that image, and you don't have to turn it into a video or anything. That's why that's there. xLight's Jukebox, I doubt anyone's using this, but if you're a user of the xLight's Jukebox functionality, you would have a version of xLight's open on this machine at the same time. And what this will do, or on a on this machine at the same time, and what this will actually do is it will send jukebox commands to xLight's to select a particular effect and put that data out. That's what that's there for. I don't think anyone's using it. There may be some quirks with it. All set is useful if you just want to set a bunch of channels to a particular value. This is great if you, if let's say you have a dumb AC controller, you have your tune to sign that you want to illuminate all the time. You can come in here and say, look, I just want to set to 255 to this particular channel. So you would say exactly which channel you wanted to set, and you would override it, and it would basically write that value onto that particular channel all the time. For instance, you can also use all set to blank something out. So it would overwrite something and set it to 0. So a set of channels to 0, or any other value in between. It's up to you. Set color. So set color is like all set, except instead of setting all the channels to a particular value, this assumes that it's dealing with RGB data. And here you would set a color. Now, I don't offer the ability for you to set the color order, so it does assume it's in RGB color order. There are ways to flip it all around, but basically, yeah, you can set a range of channels to a particular color. Projector. So projector is basically a way for you to talk to a either serially attached or network attached projector. There's a bunch of these that are all predefined. These are all taken largely from FPP. There's a bunch of work done on a plugin over there to identify all the codes for controlling all of these projectors. And you can come in here and there's a whole bunch of different commands that you can send to your projector if your projector supports it. Lots of projectors don't. Typically, these things are on the higher end projectors, not the cheapies that you might find. So you choose the command. There's often a parameter. There might be an IP address if it's network attached. You may have a password to protect it, or you might have a COM port if you're using something like one of these. You could have a COM port that you would choose, and this would send that command to that projector to turn it on, turn it off, mute the display, etc., etc. So that's what projector controls are. Add delay. So this will just delay the whole sequence for a particular point amount of time. If you need a short pause in your show, this is one way to do it. The other way to do it would be to use an all set for a period of time and set everything to black. I would generally prefer that than just a delay, but yeah, in theory, both would work. RDS. So RDS is a little bit misnamed because this is actually optimized for the EDM. RDS, you would choose the COM port that it's attached to. The station name is a up to 8-character station name that you want to display on the person's radio, and then you can put in here some radio text. If you hold the mouse over it, you can see it gives you a tooltip and tells you how you can do things like pull out the name of the step, which is what I would generally use. And if your MP3 file happens to have title, artist, and album, you can use those as well. And you can say, playing % step name. For instance, and that would say the word playing, and then it would take the name of the step. The step in this case is called set color. That's probably not the name that you want to use, but you could come up here and change the song to, I don't know, Silent Night. So now it would say playing Silent Night, and that would be sent out as radio text. via your EDM. At the moment, the EDM or this RDS does not support dynamic PS. Dynamic PS is something that I will play with, but I'm not going to do it before Christmas. The other way that you can do it, and I'll show you this in a minute. So there are other ways to interface with the EDM and also with the VAST, and so I'll come back to that in a minute. Add process. So process basically allows you to run any program on your computer. So you can, trigger a script file. You might have another program that does something interesting or useful that you want to trigger at that particular point in time. And so you can type in the command line of that program that you would run here, and it will launch that process. If you want to launch a process that runs inside a command shell, you might need to go, command.exe/c or something, and then the command that you want to run, or you might just run an executable like Notepad or something, and it would trigger that and it would launch. You can also down here say wait for it to complete. I would generally advise against that because it will hold the sequence up while this program is running. Now, if that program's really short, maybe that's not such a big deal, but maybe it is a big deal. So it's up to you whether it waits or not. Where are we? We're not even halfway there. A test is really useful. I find this really useful to run just before my show starts. So for the half hour before my show starts, it triggers a playlist which has this test playlist item in it. And there's a whole bunch of different modes here. These are actually very similar to the test modes that you would see in xLights. And so, you can set it to A, B, C, all, which is obviously, going to be red, green, blue, all, depending on how your controllers and your lights are configured. And you can set a limited range of start channels if you want to. This will max out. So my show's about 59,000. So if I put 60,000 in there and then don't press enter, which I just did. Where's it gone? Where'd it go? Okay, that was interesting. Not sure why I did that. I set that at 60,000, it maxes out on my channels, and I can put it in that test mode, and it will set all of my show for 60 seconds in this case to move between A, B, C, and all. You can decide how long. At the moment it's going to change color every half second. You can change that to be whatever you want, and it will just send that data out to your show. I find it's really useful before my show starts because I can go out and check that everything seems to be on and that there's no pixels out or anything else. So that's why that's there. So you can now schedule that. Microphone. So microphone's sort of a first attempt at adding some interactivity. So basically what this will do is it will actually listen to the computer's microphone, and obviously you can extend that microphone out wherever you want, and it will overwrite a certain number of pixels with a color whose intensity varies depending on the volume of the sound that the microphone hears. So you could have an element or even a group of elements or a group of channels, etc., that depending on how much the noise they make into the microphone, their color will change or the intensity will change or whatever. I don't know how useful it is. You do get to change the blend mode. So you could, for instance, use this to say, you would play your normal sequence, the normal thing on your matrix, and the more noise the kids make, the more bright that particular element becomes, but it would still play the sequence. So you'd still see all the normal data. Also possible. In that case, you might want to choose the average setting so that it averages out the brightness. So you'd make this white and you'd make it average. And then depending on how much noise is made, that particular element would get brighter and brighter, but still play the original data that was in your sequence file, for instance. Curl. So curl, for those not familiar with the term, is a program typically available on Linux systems. Basically, this just calls a web API or a web address. So you might have here I don't know, you might have your website, you build on your website a process that allows, like an API that allows you to say what the current song that's playing is on your website, and you would then put that URL in here, and you might say, you know, I don't know, www.mywebsite.com/ you might create a page called update song, I don't know, PHP ? And then song equals, and you might put in here %step name, for instance. Now, obviously, you'd have to write this update song thing, and this would potentially update your web page. Or maybe you want to do it as a post, and in here you want to do a bunch of JSON. You can do that as well. So you can form up any web request you like, and at that point in time in the song, xSchedule would execute that curl request and send that data off to that website or trigger whatever else it is you want it to do. Serial. So this is useful if you've got a serial attached device. Maybe it's a projector that we haven't defined a predefined sequence of data for, etc. And you might want to send that data out to that particular serial device, or maybe you've got another serial device which, you know, is something different entirely. I don't know. You know, in theory, this could even be, I don't know, an Arduino listening on a serial data stream or something, doing something interesting. You can put binary data in here. You just prefix it with the /x00, would send a binary 0, for instance, out to that device. And you can, of course, include the text, which is things like the playlist name, etc. So maybe you build an Arduino, it expects a serial data stream containing the song, and then maybe the Arduino displays that onto a little locally attached matrix or something. I don't know. Who knows what ideas people will come up with.
Keith, Tom has a question for you.
Sure.
On the curl,
Yep.
does that have to be done per song, or is that done globally for?
So all of these playlist items are placed into steps. So if you want to do it once at the beginning of your playlist, you can do that by creating a step at the beginning of your playlist and say, play this only once, and it will go off and do it. If you want to send out the name of each song each time it plays, then yes, you have to add the curl command to each and every step to send that data out. There's not a way to say, do this curl, but do it for every step.
Right.
That doesn't work that way. No,
Okay,
you've got to put it in at each step.
Thank you.
It's a little bit of work, but it's not a huge amount. FPP event. So FPP has an eventing system which allows you to send events to an FPP, and then based on that event, you can trigger a script, play a video, do whatever else you want to do. Basically, you have a set of major and minor IDs, which are the way in which FPP identifies the events. Up here, you'd put the IP address of your Falcon, and you can send that event at that point in that particular song, etc. And that allows you to trigger something to happen. Maybe you want some video to play on a remote Pi or something. That's one way to do it. A lot of these things have a delay parameter here. This is the number of seconds into the step that this particular item should wait before it happens. So for instance, if you want to trigger this video in 60 seconds into a particular sequence, then you put 60 into here. And what would happen is the sequence would be playing, and 60 seconds into the sequence, this event would be sent out to the Falcon Pi player and would trigger whatever action that Pi player is set up to run on at that time. Add command. So add command is where xSchedule starts to get itself into knots, but basically what this allows you to do is trigger pretty much almost any of the API calls. So you could, for instance, in a particular song, tell it to go off and play another playlist, or to change the volume, or to change the overall brightness, or anything it is that you can do via the API, you can also include in a step inside a schedule to get it to go and do something. So maybe you want to trigger an event playlist to play over the top of your show at that point in time. You can schedule that. So I can come down to play event playlist, and I would put the playlist name and the step name in here. And at that point in the song, that event playlist would kick in. And remember from our pipeline, right? So what would be happening is our song would be playing, and at that point in time, it would add something into this event playlist, which would then temporarily overwrite the data within the song at that point in time. And depending on what type of event playlist you kick off, it might loop, it might not loop, it may play through once. It's up to you. So that's command. That can be very powerful. Add OSC. So OSC is a standard for sending commands in shows, and this allows you to define an OSC event, which you send out to something else that understands OSC. I'm not going to get into defining OSC. If you'd like to understand OSC, I suggest you do a bit of Googling, because there's a whole bunch of information out there about it. Adding a screen map. So a screen map is the way in which you can use xSchedule to actually place a real live video onto an element. What it basically does is you have to define a matrix, just like you would with Tetris or a virtual matrix, etc. You have to describe a matrix here so that xSchedule knows how to put the data out onto that element. And then what you basically do is you choose an area of the screen. That area of the screen is typically the same size as the element, and anything that appears on the screen at that position will actually be mapped out and displayed on that element in real time. So if you want to set up a webcam and you want that webcam to appear on the song, maybe imagine you've got a sequence is playing, and at a point in the sequence you want to have the images from a webcam displayed on your matrix for a portion of the song. Okay, what you would do is you'd set up one of these, and there is no delay here, maybe I should add the delay, and you could have it actually just webcast whatever appears on that camera on that display element for that period of time during the song. Also possible. Add text. So text is the way in which you can do things like place, if you were building something which you wanted to display SMSs onto your show, or maybe you want to show the number of days to Christmas. Big hint here, the right way to do this is not in xLights. The right way to do this is using something like this text element here in xSchedule, or the text plugin in FPP, because obviously the number of sleeps to Christmas actually changes every day. And so the text item provides you the ability to overlay text on top of your sequence that's playing. Again, you need a matrix to write the text onto. You have different types of things. So normal will just display the text that it's told to display, but you then have countdowns. So countdowns, say the number of days to Christmas, etc. You'd use something like that. Or countdown seconds just counts down a particular number of seconds. And you can even read the text out of a file. So you can have some other program write something into a file, and then the text effect will read the file and display that text as well. The text here is this is the dynamic element of the text. So, you might put someone's name in here, and then the format allows you, this is the actual thing that gets displayed. So you can say, hello, and then %text, and so that %text is actually replaced by this thing up here. And the reason these things are kept separate is because there's actually an API that allows you to control this value. And so if you want to be able to dynamically set the name here, but you always want to say hello, you'd set up it this way, and then you'd use the API to dynamically insert someone's name in here, for instance. You can, of course, just put everything you want to do directly in here. That's fine. But you can also, if using the countdown, you will also want to format it. So if you want to say, current date, time, always, it never stays as long as you'd like it would to. Yeah, one of the things is missing. Oh, there it is. So if you've got it in countdown, you can say something like, percent CDD underscore days percent sleeps until Christmas. And that will display the number of days. And what you would do here is you'd put the to date. So you'd obviously put 2018/12-25. I prefer dates in this format because there's no confusion. Crazy Americans put the month first, God knows why. The only place in the world that does that. And so this way there is no ambiguity. It's clear that this is always year, month, day. Better way to display dates. So yeah, that's an easy way to overlay that. And obviously it updates automatically from day to day. You don't have to load new sequences to say the number of sleeps until Christmas. You obviously have control over font and movement and speed and all of that sort of stuff. So, render when text is blank. So for instance, if you're overlaying, I don't know, SMS messages and you don't have an SMS message, if you set render text when it's blank, it will actually still blank out whatever element it's writing text onto. If you uncheck that, and maybe you had this as normal, had this as blank, and then you had this here as percent text, and there was no text here, then what it would do is the text effect would not in any way overwrite whatever was there. So if you want it to only overwrite the text when there is actually text there to display, uncheck that box. That's the behavior that you'll get. That's the text. There's a lot of power in the text effect. Adding a file. So this is really useful. This is how you would add support for something like a vast RDS, or if you want to use the actual program that the EDM transmitter provides for configuring the EDM transmitter, you can do it here. So what you can do is you can specify a particular file, and then you can put content into that file. And it will just replace whatever these variables are, etc. So if you just want to put the name of the step that's currently running, you would do it like that, and you could put that into, I don't know, c:/fred/playing.text. Right, and then I would I'd come down and I'd run. That's it. I'd come into, so this is the VAST program. So down here you have this periodically update from file, and so in here I'd type in, it won't let me type it, but I put in this cFredPlaying.txt, and that would grab that text out of that file, and so xSchedule would write into that file every time it got to this item, the name of the step, and then this program would pick that file up, and it would then output that data to your VAST transmitter and display it. And you can do a similar thing with the EDM software, pick stuff up from a file. So that's the alternate way to send out RDS. It just requires you to have that additional program running alongside it. Add fade. Fade is basically an element that, an item that allows you, you'd use this as an overlay typically, either as an event or something, and what it will do, or you'd add it as another item inside a step. And what it will do is it will fade the data that has already been rendered into the buffer. So you would typically run it at a higher priority, otherwise it's not going to do anything interesting. And it might lower the brightness. At the beginning of the song, you'd have the fade out. And so you'd say remainder of the step time. Let's imagine the sequence runs for 60 seconds. So I might delay this for 55 seconds. And what that means is it's going to fade out whatever channels. In this case, it will do all the channels. For the last 5 seconds of the song, it will steadily reduce the brightness. If you wanted to do a fade in, you would typically not have a delay, and instead you would say for the first 5 seconds, I want to fade the song in, and so it will fade the song up during those first 5 seconds. Obviously, you'd have a priority that was maybe a 10 or something because you want to apply it later rather than earlier in the step. When you have multiple items in a step, so see here I've got this step called Silent Night, and I've been steadily adding all of these things. All of these things run in parallel when this step runs, right? So you can have as many things running in here as you want, and they will all play simultaneously during this step. Let's talk about the web interface very briefly. You've all seen the web interface. From here, the easiest way to get to it is Tools and the web interface. There is a bug currently in 40, which is a bit of a pain, but I fixed it for the next release, which will come out shortly. Just sometimes you get 404s. I've now worked out why that happens, and I fixed it in this version, so I'm cheating. Basically, the web interface offers you largely all the things that you might want to use at runtime. The way to get to the web interface is typically to go to this web address down here. So 192.168. So yeah, you go 192.168.0.109. When you're on the same computer, okay. Okay, that's interesting. Not sure why. Oh, I know why. I've currently got it set up listening on port 8080. So up here in options, you do get to choose which web server port it listens on. A browser by default expects the web server to be on port 80, which is why it didn't work. You can set it to port 80, but on some people's computers, you might have some other program that's running as a web server and it may already be on port 80. And so you can come in here and change which web port it listens on. When you do that, when you type in the URL, you need to add the colon and the port number in order to get to your website. That's why that happened. You would type in exactly the same thing on your phone if you wanted to get to it on your phone. Now, it needs to be on the web, on the same network as your computer. So you have to be able to get to your computer using that web address. And given that this is a private IP address, it means I have to be on my home network in order to access it. If you want to access xSchedule from an internet attached device, I would generally not recommend it. The reason is I make no warranties whatsoever about the security of this web server. In fact, I would argue that it's inherently not secure because I give you the ability to trigger things like playing, running programs, etc. So I wouldn't recommend it, but if you really wanted to do it, you would typically set up on your router a port forward, which would route your home's external IP address into your computer here using this port number, and that would in theory allow you to have your phone running on your phone's network, on the public network, accessing xSchedule via your home IP address. It's possible, I just don't recommend it. But if you're on your home network, it's extremely easy to bring this up, and then you can play a playlist, you can jump to next songs, you can go to the plugins here, whether it's the big buttons or the new not so big buttons, and these things all dynamically adjust to screen size. So if you were running this on a smaller screen, like a typical phone, etc., you can see that the whole format of the page has changed slightly and been optimized for your device. But you can still get to everything. So you switch to plugins, the big buttons. You can see the big buttons has slightly fewer buttons displayed horizontally, and they're a lot bigger, but it's the same concept. Now, I know people hate looking in them, but the view log here is wonderfully useful if you are troubleshooting. Now, a lot of people get really scared by the logs, but if you're someone who's going to start playing with advanced, and this is all about advanced, then you've got to stop being scared of looking into logs. Because often, the problem is unlike xLights, so xLights is a user interactive program. I expect the user to be sitting there in front of xLights when they're using it, and therefore we can display error messages and pop up and interrupt your flow and tell you to do this and tell you to do that. Everything's good. But when it comes to xSchedule, the reality is I expect this thing to be running on its own, unattended. And by default, my preference is to just go through and ignore errors. And the reason for that is because at the end of the day, you want your show to be playing. You don't want me popping up a dialog box, stopping your show just because I've noticed that something's not quite right and not working as expected. So what that means is instead of popping up dialog boxes and telling you that things aren't quite right, I just log that particular information into the log file, and then I choose to ignore it and I keep going. So if you want to understand, well, why is something not quite working as expected, you've got to suck it up and start looking in log files, because the log file will tell you what happened. Everything in the log file is time-stamped. Basically, the date, the time after the comma, this is the millisecond, so you can see exactly what time it happens. This number here is just the the thread ID. So sometimes that will change because xSchedule is very multi-threaded, just like xLights. You can ignore this. This is just what we call the log file. This part here is the severity of the message. Most things are informational or debug, and you can you may want to look at them still, but you don't need to look at those necessarily. But if it was, for instance, and you should always put the square bracket, if you want to see the warnings, you would search for it like that. And so here it's telling me that we just processed a really slow frame, and that's not, generally speaking, a good thing. Or if you want to see even more severe things, you'd search for errors. Right here, we've got an FSCQ file that could not be opened or closed. Although it doesn't actually say which one it was. I'm not sure why. Even more severe are the criticals. We've got no criticals. So when xSchedule crashes, they're logged as criticals. So yeah, don't be afraid to look in here. You'll see, things which tell you about slowness, etc. And if that's happening a lot, that's a bit of a problem. The reason why you see so many here is I was probably debugging at this point in time, and so that's actually quite common. My logs tend to be very messy. But don't be scared to go in. So when a playlist is playing, okay, so this is when it started. I haven't actually played a playlist here, so you're not seeing it. But you can see that every minute here, right on the minute, it's checking to see whether anything should be playing. So it's checking each of the schedules, and it comes up and says nothing should have been playing, and so nothing was playing. So it'll tell you, oh, I started this step. It'll tell you what audio file it loaded. It'll tell you what the bit rate was. There's a whole bunch of information that gets logged. Don't be scared to look in here. It can be useful, even if it's a little much. That's where search becomes very useful. In GitHub, which you all have access to, inside, I'll show you how to get there. So if you go GitHub, Sean Megan, xLights, this is where all the xLights source code is. There's a hell of a lot of stuff in here, but inside the xSchedule folder, there is a document here called API documentation. This is the only documentation that exists on the web API. The web API is defined because it's a very easy way for you to integrate an external program or a website with the xSchedule. So this is the same document, but it's a little bit bigger. The web API is fairly simple. There's really only 4 URLs. There is a login URL which you need to use if you've set a password on the website. There is a query API which has a number of different queries. There's a get playlist, which tells you all the playlists that are there. There's a get playlist steps. So you, having got a list of the playlists, you can then query, well, what are all the steps inside that playlist? There's a get queued step. So if you're using the queuing functionality and you want to know which songs are in the queue, you can call this and it will give you a list of all of the steps that have been queued. You can get a list of matrices that have been defined. So if you're going to put up a text element from some web program or some external program, you might want to know which matrices you can put it onto. And you can also get a list of schedules as well. And this gets the details and so forth. So there's a whole bunch of query type APIs which allow you to get the data. Now, of course, this program here, or sorry, this website here is calling exactly those same APIs. So if you hop into, if you go into C, program files, xlights, there's a folder here called xSchedule web. And your xSchedule web is this website. It's all in here. In fact, if you want to copy xSchedule web and call it, you know, your website, you can actually go in and start to change the website. And within xSchedule, under Edit Options, you can change this folder here. So I could create an xSchedule web 2, for instance. I could come over to here, copy this xSchedule web folder, call it xSchedule web 2, and then I could start modifying all of these pages and scripts and everything else. And now when I try to access a website of xSchedule, it will be your website rather than my website. What I don't recommend you do is don't change the files actually in the xSchedule web folder. And the reason you shouldn't change the files in there is the next time you install xlights, this will all get overwritten. And so if you've built your own custom website, you're probably not going to want that. But if you start to look into the JavaScript files, etc., all of those API calls, the same ones that you see there, are all being called out of here. Now, by default, the API is presented to you, sorry, if I get to the right page. It's all being, these are all being presented to you as largely get and put requests. It is also possible to open up a WebSockets connection, in which case it runs a little bit faster, and you'll find that actually the website is largely set up to use WebSockets to make it much more responsive. So there's the query API, and then there's the command API. And the command API is the API that you use to send all of the things like, you know, start and stop playlists, add event playlists, where if you want to queue up a particular song, it'll be in here somewhere. The beauty of it being a document. Okay, so enqueue playlist step. So if you want to add a playlist step to the queue of songs that are going to be played, this is the API that you'd call. If you want to erase everything inside the queue, this is the API that you would call. Okay, so it's possible to, you know, and you can call this from another website. You can write your own little program that calls this API. All possible. Just takes a little bit of development effort. But for those that really want that advanced functionality, it's really useful to use. So Postman is a program. This is available via, well, I download it via Google. If you go to the apps, you'll find an app called Postman, which you can download, and then it tells you that they're about to decommission all the apps. And so then you go and download the desktop version, and this is it. The way you would do this, let's say we wanted to find out what's playing at a point in time. What I would do is I'd grab this text here, and I'm going to post it into here. Now we need to fix this up. So we're going to use localhost because it's running on my current computer. We know that it's port 8080. I am going to go back here and change the website back to my default website before I do this. Okay, so that's the right host and port number. We're going to do a query. So which query are we going to run? Well, let's go back to our API, get playlist, get queued steps, get buttons, stop. Oh, where are we? Get playing status. This sounds like the sort of thing that we want to do. So we'll grab that. We'll go back to Postman. We'll put get playing status in there, and get playing status has got no parameters, so we'll blank that out and then we'll send it. And this is the response that that xSchedule has sent back. It sent back a whole bunch of details about it's currently idle, it's not currently outputting to lights, the volume's set at 100%, the brightness is at 100%, the IP address is, this is the loopback adapter because we sent it to localhost. This is the version of xLights that's running. The reference, let's ignore that for the moment. There's no password set. This is the time on the computer. Here are all the controllers that xSchedule knows about, and they're all offline because I don't have anything plugged in. Now, if we were actually playing a song, I'm pretty sure let's turn the sound off. It's the last thing we want. So if I click play selected, so now there is something playing. I resend that API, and now what you're receiving is a whole bunch of additional data about which playlist is playing. We're currently in step TH6. It's not looping. We're currently 4 seconds and 528 milliseconds into the song. The song is 46 seconds long, so a huge amount of information about what's going on. Right, and so you can take advantage of this information. If you wanted to build something which allowed people to vote on the next song, you could have a little daemon running that was querying this API to work out when it was 5 seconds from the end, and then you'd maybe queue up the next song. All of that sort of stuff, also possible. All right, let's talk a little bit more about a couple other things. Under the modes, we obviously have all of these remotes and master modes, etc. Some people, if you want to set up xLights as an FPP master, you would do it up here, and that would then send out the synchronization packets to all of your remote FPPs. If your FPPs are on the same network, this will work fine. If your FPPs are maybe on another network and you have to go through a router to get to that other network, what you'll need to do is set them up as unicast remotes. Why did that? And then you'll need to edit here and add all the IP addresses of the FPP remotes in here. And what that will do is, instead of doing a broadcast out to those remotes to say, this is where we're up to, this is where we're up to, this is where we're up to, what it will actually do is it will unicast those out. And because it's unicast is routable. And so you can say, go through this gateway and send it to this network and find that particular controller. And so, yeah, there are circumstances where you might want to set those up here if that's the sort of network structure that you have defined. So give me a use case. What are you trying to do with your background sequence?
Trying to turn on some static lights that will just stay on. Some boxes, some enclosures, okay, stuff like that.
All right. Okay, let's do that. Help if I have my mouse on the right screen. Okay, so what we're going to do is we're going to add an advanced playlist. All right, and this is, let's call this static stuff on. Okay, now because it's static stuff on, there's a particular set of channels that I need to set. So I'm going to use the all set item. And what I'm going to do is I'm going to set the duration. Let's make it 30 seconds because that way it'll just loop every 30 seconds. The value I want to set is 255. I want to limit the channels, and let's imagine I've got 3 items that I want to turn on. The first one is on channel 45. There's just one channel, and I want to overwrite it. The priority is not going to be important because it's a background sequence, and background sequences always get applied later. I'm going to add another all set in here because it just turns out that this other next channel that I want to do is not contiguous with the previous one. So again, I'll set this at 30 seconds. I'll set the value at 255. I'm going to limit the channels, and let's imagine this one starts at 60 and it's actually 3 channels that I want to set to always on. Okay. All right. So now we're setting channel 45 and channels 60, 61, and 62 to always on. Okay, so static stuff on is there. So now we would go up and we would make this our background playlist. We would choose the static stuff. Expand this out if we wanted to. And so now when the schedule is playing, so if I play this playlist, this stuff here will also get applied. And if we remember from our diagram, what will happen is our sequence will play and then our background playlist will overwrite the data. And because we've only set particular channels on, it will only override those particular channels and turn them on. Now, if we want them on all the time, even when the show's not playing, we need to go up to our options and we need to run our background playlist when we're not running a sequence, right? And we would also probably need to send the data out when not running a sequence as well. But I'm not going to do that because it's just going to fill my network up with data. So on the Pi, it's possible to set up events. So you can come in here and you can set an event. I don't know, let's make it a major event 3 and 3. Click save. Oh, hang on, add event. Okay, event ID. So we'll do 3.3. There it is, 3.3. Give it a name. Fred, I like calling everything Fred. You can either say a sequence or a script. I don't have any scripts defined, which is a bit of a problem. I would have to go up to, I think it's File Manager, Scripts, and I'd need to add a script in here if that's what I wanted to do. And then you'd come back to xSchedule. Let's add another advanced playlist. And we would add an FPP event. And we would set the IP address of our controller. Our FPP, which I think is 81. We would set this to 3, this to 3. And that's it. And that's how, and then you would play, when you play that playlist, it would send the event to FPP and trigger that event, which would run that script on that FPP.
And that could also be a background playlist?
Yeah, but think about it. Think what's going to happen if you set it up as a background playlist. So it's going to loop around and it's going to send the event every time that background playlist expires. So if you came in here and you set, because you can't set a duration on this, it just runs. So what else could you do? Well, I guess you could add a little delay in here and say, look, delay this. Actually, what we'd do is we'd add a step. We'd grab our delay. We'd put our delay up here maybe. And I don't know, let's say you wanted to trigger that event every 5 minutes. That would be every 300 seconds. You would probably want that step to run first. So you trigger your event, you'd sleep for 5 minutes, and then you trigger your event again if that's what you wanted to do. But yeah, generally you wouldn't send FPP events using a background playlist just because the background playlist just keeps looping and so the event would keep getting sent. Okay,
makes sense.
Right. But what you could do, for instance, is let's imagine you wanted a button on here to trigger the event. So you've got a Pi out there which has got this script that you want to run, but you want to control it via the xSchedule buttons on the web user interface. You can do that. So what you can do is you could come up here and go to options. You could say add run FPP script. Okay, we've got this playlist, unfortunately. I could run this event playlist step. I'm going to call it playlist and step. Okay, I'm going to click OK, click OK. I'm going to change this. I do need to rename this to be PL. And I'm going to send this event here. So I need to give this a name, which was step, and click OK. So now I've got this. Why did that not? Okay, it is step, it's named step. And so now I've got this run FPP script. So if I click this button, it is going to play this particular step, which is going to send event 3.3 to my FPP. And because I've set it up as an event playlist, it won't interrupt my currently playing sequence. It will run on top of it and send that event out to that FPP. So if you've got that FPP set up to, I don't know, display some text to say turn your headlights off, or to trigger a video, or to run a special local sequence on a set of props, you can trigger it using that button. And if you now went to Tools, Web Interface, and we go to the buttons page and scroll down, it would help if I had control on my mouse. There's my run FPP script. So I can now trigger that off my phone and run that script on my FPP.
Got a question in chat. Is there a way to turn on an outdoor speaker while playing a playlist? He was thinking of using a DMX relay module.
Sure. So yeah, if you wanted to schedule that, it's just a matter, again, you're sending a particular channel of data. If it latches on, you obviously just need to send a single frame with that data set. If it's not latching on, which means you have to keep sending the data, then again, you'd use that all set.
Right.
So if you said, look, during, I don't know, let's say during this particular sequence here, I want to just set that relay on, I would add an all set. If it latches
for a playlist, because I'm the
sorry,
one.
So if you want to do it, well, again, if it's
Right.
latching on, you could add a step at the front here.
Won't
Right.
latch on.
You'd set it first step only once, and you could do it there. If it doesn't latch on and you need to keep sending it, you could do something really funky, like say, add a command. And I could come up here and there's a command down here which says set something as a playlist. So I could set that background playlist just for this particular playlist. And then at the end, you could add another step at the bottom, which is down here, you'd go and add a step. And you could add another command. And that command could do something like clear the background playlist. So the first step sets the playlist, the background playlist. The last step removes the background playlist. And in the playlist, you would just make those steps run once only. All lights off button, can we do something to say all lights off? Well, let's say you wanted to blank all your lights, but you didn't want to stop your playlist. Maybe you just want to mute your lights so that people stop turning their radio off or whatever. You can absolutely run or add buttons that will do that sort of stuff. Again, you'd go to options, add. So if you just want to mute your show, you can do that by going to the set volume to, actually I think there's a toggle mute. which is an even better button to have. So you can add a toggle mute button, and that will drop the volume to 0 when you press it, and when you press it again, it will restore the volume to whatever it was before. So if you'd played with the volume before, it would restore the volume to that. Let's say you wanted to actually, instead of muting the sound, you wanted to mute the lights. So there you could do that, but it's not as simple because there's not a mute, but there is a set brightness to N%. So you could set that to 0%. But you would probably need to add an unmute lights, where again you would set the brightness to 100%. And click OK, click OK. And so now I've got the mute lights and unmute lights buttons down here. Someone asked, can you schedule everything to come on and off at dusk or at a specific time? And absolutely you can. I could add you do that in the scheduling. It is possible for you to type in sunset in here. So this will come, the lights will come on at sunset. Now this is sunset, official sunset time. So I'm not looking outside to see how dark it is and deciding it's sunset. It's actually setting it based on where you happen to be in the world. So in order for that to work accurately, so right now, sunset says that it's going to kick off at 8 o'clock. I think that's, yep, sunset's 8 o'clock here today. It's interesting that it's exactly there. But if I was not here in Sydney, if I was in, I don't know, let's say I was in Vegas, I could do that. Okay, why did that not work? Saw it was sunset. Down. Oh, there it is. 11:41 doesn't sound plausible. Not sure why that is.
Is there a time zone involved on your?
It could be. It could be a time zone. Yeah, it could be a time zone. Let's choose somewhere a little bit closer. Now, not every city's here, funnily enough. Then I have to go in and redo this. Yeah, so 7:25. Yeah, I didn't have a city, so it was 8 o'clock. So yeah, 7:25 tonight, the sun goes down here in Sydney. And so that's what time. And obviously every day it moves slightly. And so your show will start either progressively early or progressively later, depending on what part of the world you're in. Okay, now typically sun goes down about 20 minutes to half an hour prior to it really getting dark. So you've got to be wary of that. It goes when the sun drops below the horizon is what this is doing.
I sequence on a desktop, but I have xSchedule running on a laptop. When I sequencing, I save the file. It has a cloud synchronization program. So the laptop is reading from the cloud service. And so I'm just wondering, you know, how often does xSchedule look to see if the files have been updated? I just played around with this for Halloween, so I didn't have a lot of time to look into it. But it seemed like if I saved a file, it wouldn't refresh in xSchedule unless I closed it and opened it back up. But that I could be totally wrong there.
So you can update a file while xSchedule is playing. The problem you've got with these file synchronization services is you're synchronizing the FSCQ files. The FSCQ files are massive, and so they don't copy over quickly. They take a long time to copy over.
Right.
And xSchedule, only while it's playing a sequence, it will open up that FS sequence file and it will start reading from it. Your problem is if you're running one of those cloud synchronization services, it goes to update the file and xSchedule's got it open. Well, while xSchedule's got it open, the cloud synchronization service will say, "Hey, well, I can't update that file. Someone's got it open."
Okay. Yeah. What I was doing was I was opening up the window to watch the sync, and it sometimes takes, you know, half hour, at
Exactly.
times, you know.
Which is why we would not, generally speaking, advise people to move around their FSCQ files using that method. We would you either re-render it on your playing computer, which is what I do. I just fire up xlights, I click render all. I use GitHub to have all of my sequence files, etc. So I just pull it all down from GitHub, make sure I've got a pristine show folder with everything in it. I then go and do a batch render. It renders all my FSCQ files, and then I play my show, and it works perfectly every time.
So if I were to do that, do I have to have the same directory structure as on my desktop to make it work, or am I? Okay.
Yeah, you would. I mean, it's either that or you stop xSchedule. Sorry, we don't even need to stop xSchedule. You can leave it running, but you just copy across the files directly.
Okay.
That's also doable. Like to say, the problem is that, you know, because it takes so long to sync, xSchedule almost certainly opens the file, and then you run into conflict issues with your synchronization service. It's got nothing to do with xSchedule. It's doing exactly what it should do. It's playing the show.
Okay. Gotcha. Okay. Thank you.
Are you using Dropbox by chance?
No, I'm using a pretty unknown service called pCloud.
No.
They give you a lot more storage. That's why I went with them.
Yeah, I was just going to say for Dropbox, you may want to make sure you enable LAN. It copies it over way faster because it goes across the LAN and not the cloud.
Oh, I'll see if they have a similar setting. Thanks.